Okay, or else you can also put the your questions in the chat box. So once again, welcome you all to this live session of week 5. So let me share the slides. So okay, so good evening everyone. Welcome you all to the live session 5 of the course Solar Energy Engineering and Technology. So in this course, how I planned this live session, we'll first start with discussing the different concepts that has been uploaded in the lecture slides, and after that we will also solve the numerical questions. So if there are any numerical questions, I think most of the numerical questions are based on the whatever is taught in the course. Or if there is anything which you need to understand, so okay. So if there is anything, so I guess, am I audible to you all? So in case the connection breaks in between, so please remind me. Anyone can switch on their mic and remind me that case, sir, you are not audible. So I will try to connect again with my microphone. So it's a Bluetooth microphone, so sometimes it happens that I could not get whether I'm connected with you guys or not. Okay. So yeah, Vani Sundara is saying yeah, it's audible. Okay, thank you, Vani. So we'll go ahead with the live session. So first, I will try to discuss with you guys different concepts actually. Sir, I am unable to solve any numericals. I want to know which data will be available to solve numericals. Which data? I don't think any data will be available to solve numericals. I'm not quite sure what you are talking about. So numericals will mostly be formula based. So all those formulas and everything are given in the lecture slides. So I suggest you guys to go through the lecture slide at least once. So when you go through the lecture slides, you will be familiar with the type of numericals that are asked in the assignment questions, and those numericals are much easier. You can solve it by yourself. So today only we will try to solve them. Okay, so you will see that these questions are easy, and you can try to have an approach for them. First, there is an approach to solve any numerical. You need to read the question, you need to understand the question, what is being asked in the question, then you apply the related relations, formulas, or anything, then the answers come as it is. Okay, so that's not big problem, Sandeep. You will be able to solve the numericals. Just try to solve more and more numericals. Okay, get a good book of any solar technology, solar uh, related technologies. So there are lots of numericals in there. Try to solve them. Okay, so that will help you guys to have a familiar view of whatever is being taught in the lecture slides, whatever is there in the assignments. So, and don't worry, we will be solving the numericals in the assignment problems, because in this live interaction session I will be taking the assignment problems of the previous run of this course, so we will also solve the numericals here. Okay, so that's not a big issue, we'll tackle that. Any more questions from anyone? So can we use data of slides? So what will be the data? So I have told it repeatedly. Data is not something which is needed. So most of the data that you will need is will be given in the exam. So I don't set the exam question papers. It is already set by the professor, so he knows. I think these doubts you can raise on the this discussion forum of the NPTEL. Okay. So with every course there is a discussion forum, ask a question. Okay, so you raise this question there, so professor will be able to answer that. But be sure that whatever data you will is needed will be provided in the exam, will be there in the question. So I'm not sure whether you are asking about the data or the formulas needed to solve the questions. So okay, any other doubts from anyone who wants to ask his question? Nishit, yeah, go on. Okay, so like there are some very big formulas. So don't worry. Like in assignment question, you have seen that if a big formula is required, it's already given in the assignment question. You have seen now. But the small formulas like the angles, formula related to angles, formula related to calculation of daily solar irradiance, these things you have to remember. Okay, so small formulas you have to remember. The big formulas will be given in the exam. But be on safer side, have a look at all the formulas. It's better to memorize those formulas, because that will help you if maybe the exam, maybe in the exam those formulas are not given them, then it will be very difficult for you to solve. Okay, so I'm not sure whether I don't think so calculator is allowed. There is on-screen calculator there, so that will help you in solving the numericals, so don't worry about that. So before any exam, before this NPTEL exam, there will be a set of instructions that will be posted to your mail also, and on the announcement section also. So go through that mail. It will all the information that you are asking to me or is needed by you will be mentioned in that mail. So that mail will help you a lot. Okay, so don't worry, those the mail will be sent something around 10 or 20 days before the exam, or always go and check the announcement section. If this mail is there, you can have a good look at it. Okay, anything other than this? Okay, so I think I've answered your queries regarding the course. So I think we can proceed with the discussion of lectures now. So what I will do, I will not go through each and every point of the lectures, so that will be very boring. So I will pick some points, like some diagrams where you guys need to have a good concept. So I will only discuss those points, and I will leave those slides on the screen so you guys can see it. You guys can raise doubts or question about it, so we can have a good discussion on that. Okay, so that will help you guys, and also will help me to answer your queries. Okay, okay, so I'm starting with lecture 13. So I want to be discussing each and everything. So mainly you guys have an idea about this standalone system. So standalone are something which are based on their own. So it doesn't have to be coupled with some grid or coupled with some other system. So these are the standalone systems. So in most of the house which you will see like in government sponsored scheme also, these standalone PV systems are installed on the roof, and whatever electricity is produced, so these electricities are actually stored in the battery banks, and then through battery banks an inverter is there that converts batteries DC supply to AC supply, and then the it takes almost I think 1 kilowatt of load of your house. Not a very big system is there, but it takes around 1 kilowatt of load. So maximum of your like your TV, fan, batteries, not batteries, the bulbs, all those things can be taken care by this 1 kilowatt system. So it is enough for a family of two or three, and can easily be utilized in home without any external support. But yeah, the standalone system has problems like if there is no sunlight and if there is night, so there won't be any power available. So in that case what you will do, you have the battery set of battery bank that actually stores the power. But if the like rain, the rainy season, the rain continues for 2 3 days, so that can have a pretty much of limitation of using this standalone system for households. Okay. So this is a pretty important slide. So I will try to explain this slide, and I will leave this slide for some time so you guys can have a good idea about what is there in the solar PV system. So you know PV is photovoltaic, that is converting photo, taking the light and converting into electrical voltage. Okay. So what happens here, we have a, let me take laser. What happens here, we have this roof, a slanting roof. So it doesn't mean that every roof has to be slanted to install this PV system. It can be installed on flat roof also with giving slightly slanting angle to it. So why it is slanted, the question is here, why the solar PV cells are slanted. So during the lecture 2 or 3 you guys went through these different types of angles of solar PV. So you guys are very much aware that with the variation of the angle, the power generation or power received actually varies. So that's why these are actually slanted to make utilize of most of the sunlight, so that most of the sunlight is actually uh, perpendicular to this, covers the maximum area of this solar PV. So actually this solar PV converts sunlight into direct current. So there is two types of current, direct current and alternating current. So I think you guys have a good understanding about. Someone wants to join. Okay. So yeah. So I think you guys have a good understanding about what is a direct current and what is an indirect current. So if the direct current are something like produced from small batteries. Batteries generally produce direct current. Alternating current is the current which you get from the grid, like electricity grid. Okay, so I will not go much detail into this direct and indirect current, alternating current. Okay, then there is a charge controller. It's basically a MPPT device. I used to convert this power tracking and charge to the battery. So there is a battery bank which stores the energy produced. Okay. Also, battery stores the energy, produce energy in direct current. So most of our devices are alternating current. So it will need it. An inverter will be needed to convert this direct electricity into alternating current electricity. Okay. So this black one represents the alternating current. Sorry, this black one represents not the alternating current. This is inverter. Then we have this load bulb and light bulb. Then we have this power meter. Actually, what happens, there is a concept of net metering. Whenever you produce extra through this solar PV, you feed it to the grid, and whenever there is something shortfall of producing power through grid, solar PV, then we take some electricity from the grid. So this is a type of a power meter. The power meter which you see, electricity meter which you see in different households installed by the electricity department. This is the same type of meter, but it has a net metering capacity. Like whatever goes out and whatever comes in. So these are charged differently and then adjusted. So a net bill can be generated for the consumer. So this is basically a standalone system. So before going to this, I will leave you guys with this slide. So if there are any questions, queries, you guys can have a good time and can raise your doubts. Okay. Okay, so if there are no questions, then we should proceed to further slides. So this is an example of standalone system. So I won't go into detail to discuss each and everything of this standalone system. It simply has this solar cell, then it stores it in the battery, and then whatever is sorry, this is not a battery. This is a yes, standalone system for water pump with no energy storage. So whatever is produced goes directly to the motor, and then it pumps the water from the reservoir. A complex PV system including batteries, power conditioners, and DC and AC loads is seen on the right hand side. So, yeah, this is important. This is a hybrid system. So, what happens in most of the cases that there is a PV module, solar PV module, then it is connected to a charge controller, then there is inverter and also battery bank to convert this DC to AC supply. And in case of like if there is night or there is a not clear sky like cloudy sky where the power cannot be produced or less amount of power is produced, then what we do that key we have a backup generator. So this backup generator actually feed to this loads of the house. So this is a typical hybrid system. So not going into much into the detail. So batteries are typically used for storing the energy. So there are different types of batteries. Most of them, the most common of them is lead acid batteries, that is PV acid battery. The main problem with lead acid battery is that it has a very low mass energy density compared to volumetric energy density, and this is basically solved by lithium ion polymer batteries, lithium polymer battery. So these are actually very much into focus in nowadays, and most of the batteries which we are now getting are based on these type of batteries. So yeah, this is lead acid battery. I think most of you will be familiar with what is a lead acid battery. So it goes to this reaction Pv plus PbO2 plus this aqueous solution of sulfuric acid. Then this when we supply the current, this reaction reverses and Pv and PbO2 are restored. This is a type of lithium ion battery. So one of the advantage of using a lithium ion battery is that it has a very high energy density. So that makes them very favorable technology for lightweight storage application. Already it is used in mobile. Okay, so ah, this I will discuss in detail because this is a very important slide. So you know a battery voltage is there. So whatever is rated battery is rated in voltage. Like we have 12 volt battery, 3 volt. Okay, so okay, so there is capacity of every battery. So capacity directly corresponds to the amount of electrode material of the battery. Okay, it very much depends on the electrode material. So there is two terms. One is voltage, that is very much dependent on the chemical reaction going on into the battery, and the second thing is capacity of the battery, that is dependent on the electrode material used in the battery. So be very much sure about what is being talked about, whether it is voltage or capacity. Then we have C rate. So it's basically a multiple of current over discharge current that battery can sustain over 1 hour. So yeah, C rate is very important to know whether the battery how much is like rate of discharge of battery can be measured with C rate. Okay. These terms, battery efficiency, voltaic efficiency, Coulombic efficiency, these are very much important. So voltaic efficiency is the ratio of average discharging voltage to the average of charging voltage. Okay, so you can see voltage discharge by voltage charge. Similarly, for Coulombic efficiency, we here it is voltage, here it will be current. Okay, so the battery efficiency is basically the product of these two. Next thing is state of charge. It's basically defined as the percentage battery capacity that is available for discharge, and depth of discharge is just like complement the state of charge. It says the percent of battery capacity that has been discharged. So you see in mobile now we have 34% of battery left for discharge. So that is state of charge, and if 34% is left for discharge, then 66% is depth of discharge. Okay, so on this is the simplification of what we see in mobile. Second thing is cycle lifetime. So it is defined as the number of charging and discharging cycle after the battery capacity drops below 80% of the nominal value. So cycle lifetime is only calculated number of charging and charging discharging cycle after battery capacity drops 80%. Okay, so this must be remembered. So this questions from this can come in the exam. Then we have temperature effects. So I won't go into detail. We have aging effects also because sulfation is there that is okay. So yeah, we're discussing this. Then we have charge controllers that are used in PV system that use batteries. So yeah, charge controllers are very much important. So it is basically amount of current sent to the battery by the PV array and the current flowing through the battery while being discharged has to be within well-defined limits for the proper functioning of the battery. So that is what the function of charge controller. Okay. So basically what happens ki directly clubbing the load with PV array can be detrimental to the battery lifetime. So that's why these charge controllers are actually installed. So that takes care of the loads and this current produce everything and get optimum scenario. So yeah, there are different problems which are actually associated with the battery banks. So most of them are actually tackled by charge controller. So yeah, this the performance will vary depending on the season, days, and everything. Then we have cables. So I won't go into detail, but yeah, there can be questions in the exam from this. So please remember this the cable color in India, like or Pakistan. They don't. I don't think, but yeah, you should know what is the cable color for neutral in India. Then we have cable loss. Yeah, this is very important. So whatever is actually voltage drop across the cable, if we multiply it with I, so it gives the power loss at the cable. So similarly these relations can be used. So there can be numericals based on this. So whatever, so many guys are asking that sir, I am not able to solve the numericals in the exam. So I don't see any difficulty in solving numericals. You have these formulas here listed in the slides. Use these formulas. These are, you just have to understand the, what is the meaning of R cable, what is the meaning of V. Just put these values and you will get the answers. So yeah, resistance of the cable. This is, I think most of you are familiar with this resistance rho L by A. So okay, so yeah, simple approach for designing of off-grid systems. So there can be simple different approaches. So Now let's solve some numericals, and then we will leave this slide for you guys to understand, and then we'll discuss the lecture 14, and then we'll discuss the assignment questions of the previous run of this course. So basically it says that 12 volt PV system has two DC appliances requiring 15 volt and 15 volt and 20 volt respectively. So what happens, total load is 15 volt and 20 volt. Okay, the average operation time is 6 hours for device A. So device A is operating for 6 hours, so total watt hour is 15 into 6 for device A. For device B it is 3 hours, so 60. So total load 150 watt hour. The daily energy requirement is, so divide this power requirement by 12 volt, that is volt of the PV system, so it will give the ampere hour rating. Another question is that an AC computer and TV set are connected to the PV system. The rated power is this. So inverter efficiency is this much. So daily energy requirements of the device is expressed in DC ampere hour. So it's same as the previous question. Based on the usage and power rating, you calculate the amount of energy required based on this computer TV. Then you total it, divide it by 0.85 because inverter efficiency is 0.85. So this much power has to be actually supplied by the PV. So divided by 12 volt PV is there. Okay, so 25.5. Generally, system loss is about 20-30%, but considering 20% system loss of DC requirements of the load equation using 1 and 2, so they have actually added these two and accounted for 20% loss. So this much is the power that needs to be supplied by DC for this system. So yeah, and there is some calculation based on the sun hours for Guwahati. So Guwahati has 4 hours. So this has 46 ampere hours. So divide by 4, it will require a current of 11.4 ampere. Okay. So number of modules in parallel. So this is for solar cell. Okay. So it requires a current of 4.11.1 ampere. So divided by 4.9. So it gives the amount of module that is equal to 3. So I think the battery system, all these things we will discuss in the next slide. So, this is pretty much simple type of question. Most of the question will be like this only. So don't worry. Just try to understand this question, and if there are any doubts, please raise them. Okay. Okay, so you guys went through the different slides. So yeah, okay, you guys went through different slides. So I think if there are no questions, then we can move to the next slide. And I won't discuss anything in the next slide, any conceptual. We just move to the directly to the numerical problem there. So what I'll say that very important numerical is there in this slide. So please be attentive. I was talking about this question. So yeah, these are the different formulas which you need to remember. So these will be required to solve the numericals. Okay. So this is the numerical which I wanted to talk about. So it says a residential house has a power requirement of 600 watt for 5 hours per night. Okay, so 600 watt for 5 hours every night. So mind it, it is proposed to meet the requirement by using a PV array, a battery, and an inverter. So there will be PV array, then battery, then inverter. The whole system is over designed so that it can meet two extra nights requirement. So yeah, there was question na कि if there is extra, so system is generally over designed, so anything extra that you produce is actually stored in the battery. So no sunshine during those days, the calculated number of PV modules and battery is required. Given that the solar radiation is available for an average of 6.5 hours daily, so 6.5 hours daily of solar radiation is available. So how much is the irradiation? 710 watt per meter square, and it's given. Battery rating is also given, 120 and 120 ampere hour, 12 volt. Depth of discharge is given, charging efficiency is given, discharging efficiency is given, inverter efficiency is also given, efficiency of the module is also given. And so yeah, this is listed here. So first thing is that we need to calculate it for 3 nights. So we calculate the total load, that is 600 watt into 5 into 3 night, that is 9000 watt hour. So first we will calculate the daily energy output of PV array. Okay, so that is equal to Ig into SPH into AM into P into Nm. So please mark my words very carefully. How do we approach this question? First thing is that we draw this block diagrams, then we list the parameters here, parameters here, parameters here, then we start calculating. You guys are not doing this, that's why you are not able to approach the questions in the correct manner. Then we Ig value is given 710. Okay, solar per hour, solar photovoltaic hours is 6.5 hours given. AM is the area of module, that is given, AM 1.191 into 0.533. Nm is the efficiency of module, that is 0.11, and P is what you needed to calculate. So multiply all this, it will be 322.25 into P. Okay. So now we are moving to load 1, that is 600 into 5 into 3, that is 9000 ampere hour. This load has to be tackled by this PV array. Now power available at load, so EPV output, that is this into NC into ND into NM, that is collector efficiency, discharge efficiency, charging, discharging, and then inverter efficiency. So this is the total power available at the load. Then equate these two, you will get the amount of power. Okay, the amount of P. So total load and power available is equal. So equating P equal to 36.4, that is 37. Now energy is supplied by one battery to the load. So one battery is there. So we take into account only one battery. So voltage at 12 volt, ampere hour is given 120 ampere hour, and discharging is given 0.8, charging is given 0.95, and then inverter efficiency given 0.95 and 2.85, and that is 930.24 watt hour. So number of batteries required will be EL, that is this 9000, that is the total load, by the load supplied by one battery, divided, it is 9.67, so we will be requiring 10 number of batteries. Okay, So you calculated the designing. So PV is calculated. Total number of batteries is calculated. The third thing is the you need to think about the inverter that is required to convert the solar PV modules, charge from the solar PV modules to the batteries. So that has to be designed extra. So generally the efficiency on inverter is given, that is what is needed, and the power load that is to be supplied. So that is the whole designing of this solar PV system for application in the house. Okay, so this is PV water pumping system, so we will not go into details. This is another question. Okay, uh, of similar nature, so let us discuss this also. So what I will do, I will uh, left I will leave you guys with this solar residential power requirement, and please raise your question, then we will go to the next question, we'll discuss that, then we will move to the assignment questions. Okay. So yeah, Sandeep, you were saying that there is a 20% power loss. So what happens ki with the load, we say that ki we are getting X amount at the load, like 100 ampere hour is the load. So we count that 20% is the power load. So what we need to be supplied by the solar PV, that is 20% extra. So we need to get 120 ampere hour from the PV. So 20% is lost. We get 100 ampere hour. That is the load. So that's why it is 1.2. Okay. So in simple terms, just multiply the 20%. That is zero point 0.2 and to 1. You will get the this. How much should be the extra capacity of solar PV? questions from, let me check here. No questions. Okay. So now let us focus to the next question then. Okay. So this question we discussed. So we'll move to the next question. A solar photovoltaic cell installed for supplying water pump for minor irrigation purpose as a remote place in a developing country. The water is pumped through a borewell at a depth of 40 meters. So this is the depth. Okay, so PV array consists of 24 modules. So each module has 36 cells arranged in 9 into 4 matrix. Okay. Cell size is this, cell efficiency is this, consider the efficiency of inverter combined motor pump efficiency at this much, calculate the water discharge at noon when the global radiation incident normally to the panel is 800 watt per meter square. Assume the density of fresh water as 1000 kg per meter cube. Okay. So first thing is that when you approach this type of question, so first thing is that you have conversion efficiency. So power output from array equal to incident solar flux into cell area. So incident solar flux is 800 watt per meter square. Cell area is this much into 9 into 4 into 36 into 24 modules. So this much into power output conversion efficiency by 12% cell efficiency. So now this much is power which you are getting as output from this array. So this will be power available to this AC motor. Now AC motor has efficiency of 85% as motor and pump efficiencies multiply with this much power will be available to this AC motor, and we have P equal to power equal to rho GQH. We know rho equal to 1000 kg per meter cube, G equal to 9.81 meter per square per second. Then we have Q, that is the water discharge that is need to be calculated, and h is the height of the borewell, that is depth of the borewell, that is 40 meters. So putting all these values, you got to know that this 1.41 into 10 to the power minus 3 meter cube per second, that translates to 5053.21 liter per hour. That is the amount of water that can be discharged with this much capacity of solar cell. Okay, so please go through this, and if there are any questions, please raise your doubts. So let's discuss the assignment questions of the previous run of this course now. So the first question is, if no load is connected to the PV system, it will be okay. So what it will do if no load is connected? Then dissipating energy in the panel and increasing its temperature. So what I was talking about this loss is like I think someone asked the question also like if more power is produced than whatever is the load. In that case here, power it will dissipate energy in the panel and the back panel temperature will increase. Okay, so the correct answer here is answer C. Now the second thing is PV power used to power a DC motor to produce 3 HP soft power. The motor efficiency is this. Each module has 36 multi-crystalline solar cell in 9 into 4 matrix. Size of cell is this. Cell efficiency is this. Global radiation is this. Number of modules required in the PV array. So this question you can easily solve. Otherwise I will try to solve here. So we have a 3 HP soft motor. So 3 HP convert HP to watt. Okay. So that has to be supplied through this solar power cell. So solar power cell has area of 0.125 and 2.125, that is 0.125 square, efficiency point number of cell equal to 36, number of module equal to x, that is need to be calculated, into motor efficiency is 0.82. Solve it and get the value of x, that will be around 40 point something, so that will be 41. Correct answer is answer D. So I don't know why you guys are saying that we are not able to solve this question. These are very pretty much simple questions. So see how I'm solving. Just putting the values and balancing the equation. That's all. Okay. Question 3 is PV system of 12 watt capacity at two DC appliances of 25 and 30 watt respectively. The average operation time is 6 hours for devices, 3 hours for devices. The total daily requirement in a pair hour of these devices. So simple, one device is 25 into running for 6 hours, 150. Second device is 30 running for 3 hours. 90. Total 240. Now battery capacity has is 12 divided by 12, that is 20 ampere hour. So this is basically MPPT, a charging controller that basically does a lot of functions. So for your sake of knowledge, I put this picture so that you guys can have an idea what MPPT is. A 10 ampere battery has been treated by 3 ampere hour said to have an SOC and DOD percent of. So we have the formulas of SOP and DOD percentages in the slides. So use those formulas. I'm not going to calculate because these are pretty much formula based questions. Okay. So the correct answer will be answer A. In PV array, reflectors are connected in series and parallel to maximize the values of. Generally, in series, we maximize the values of voltage because same current flows through it, and in parallel, we maximize the value of current. The correct answer here. An MPPT is multiple power point tracking system is basically a DC-DC switching regulator. Okay, so correct answer is C. Now this question. So I think this type of question has already been solved. Still, I will try to solve it for you. Okay. So solar PV has a driver efficiency. What is equal to 3.2, current equal to 0.15. So you can get the power 3.2 into 0.15 into 0.85. Then another thing here, consider standard configuration, standard and RPA model efficiency of this, battery charging, discharging efficiency of this, battery charge voltage is this, and depth of discharge is this, daily average global radiation and this, rating of PV module है. So first thing is that you need to calculate the power. So this is around 0.48. This is the power of LED lamp, 0.48. Then this lamp is operated for 5 hours. Okay. Total power required equal to multiply it by 5 will be 2.4 watt hours per day. Sorry, this is not. Remove this. Now ND driver efficiency is given 0.85. So total energy consumed will be like 2.4 0.85 equal to 2.824 hour per day. Okay. Now we have this much of input energy required to the battery, input to battery. I will say battery input 2.824, that is calculated here upon the different efficiencies that are counted. Discharging and charging 0.95 into 0.93 equal to 3.196. Okay. So we have around 4 hours of sunlight. How do we know that we have 4 hours of sunlight? That is I will keep this value here only. Rest I will remove. So we have 4 kilowatt hour per meter square, that is equivalent to 1 kilowatt into 4 hours, okay, per day. So in 4 hour operation, it is for single hour we will be requiring 0.8, okay. So we need to calculate the area of module, that is rating of module, that is, so let's say area module is A, module efficiency is 0.15, then we have radiation as 1000 meters, what 1000 watt per meter square from here, okay, 1 kilowatt equal to 1000 watt into the efficiency, which is I think that is equal to battery power. So area will be calculated as 5.92 10 to the power minus 3 meter square. Now we need to know the rating of PV modules. So we know this equal to, so just multiply it and equate it with this. So you will get the rating of PV module as 0.8. I think we have calculated this is the rating of PV module. WP value 0.8. 3.196 divided by 4. Okay, so I have also calculated the area also of the PV module. This is the correct answer, 0.8. Now this is yes, this one. Okay, so let me erase and then I will try to repeat it. In the last, in this one you don't need to put energy balance equation. I simply what I did here, I just calculated the power of lamp. Okay, so power of lamp was basically 3.2 into V into I. Okay, so that is 3.2 into V into I. This is the power of lamp. Then we have this 0.48 watt. Okay, so this 0.48 watt is actually consumed in 1 hour. So lamp is operating for 5 hours, then 0.48 watt into 5, that is 2.4 watt hours per day. Okay, so this is clear. Up to this it is clear. Then I will tell about next step. Up to this it is clear. 2.4 watt hours per day. How does this value come? Now the driver efficiency is given 0.85. Okay, so this is the power which is going to the bulb, and this is coming from some battery, okay, or a DC voltage device. So it has a driver efficiency of 0.85. So this power is 2.4 here. So what should be power input to this? 2.4 upon 0.85. Do you agree? Okay. So this comes out to be around 3 point, no, 2 point, where is the calculator? 2.82 something. Okay. Now this is the power which is output from the battery that has to be supplied by the battery. Okay. So battery has efficiency of this charging and discharging. So what is the battery efficiency? We multiply the charging and discharging both. So suppose this is the battery, this is the power here. So power input to the battery divided by 0.95 into 0.93. So this comes out to be around 3.2 or something. Okay, 3.2 watt hour per day. Now there is a trick here. You have a daily global average radiation of 4 kilowatt hours per meter square. Okay, so what is the daily global radiation? It is given in 1 kilowatt hour per meter square. So if it is kilowatt hour, that means 1 kilowatt hour radiation is available for 4 hours. Okay, so this much power has to be produced in 4 hours. So in 1 hour, that is actually the rating of PV module. We divide it by 4, so it will give 0.8. Okay, so this is the rating of PV module that is being asked in the question. Okay, the next step is that I balanced all these to calculate the area of the PV module also. So area is, I think, not asked in the question, but if you want you can go further and calculate the area. Okay, so is it clear? Okay, so I will go to the next question. So this question was actually discussed in the slides also. I discussed this question in detail in the slides, so I will not try to solve this question here because this is very easy question. You just have to write and balance it. So the correct answer will be here, 2774.75 watt is the output, and based on the power available for lifting water, so just multiply it with the efficiency available. So that will be something around 1373 or something. Second is third is the water discharge rate. So you write a equation in the slides also. There was equation which rated, just balance the energy. So that will be the power produced equal to rho G H Q. You know rho, you know G, you know H. You just need to calculate the Q here. So that comes out to be around 9.9180. So this was also the question. Okay, so this was the same question with change in data. Where did the slide go? So just you need to balance this and get the answers. So total number of modules required to meet the demand will be answer C50, and total number of battery requires will be A equal to 10. I think the same question is repeated here. So try to solve it by yourself. This is pretty much easy question. Okay, just you just need to balance it. So so Thank you all for attending this live session. I think we had a great discussion and we have tried to solve the numerical questions also. So that will help you in solving the assignment question. And I'm sure you will be able to solve the assignment question because most of the questions are pretty straightforward. You just need to understand the data which is given. So try to make block diagrams, try to write the data, and then you will be able to solve the questions. Okay. So thank you once again. So if there are no questions, I will be ending this live session here. So we'll meet again at next Monday. Thank you all for attending the live session. Thank you, Vani. Sir, do we have to remember all those formula which we had used today? Sandeep, we don't need to remember the formula. You just need to understand. Today is no formula. We didn't apply any formula. We just balanced it. P equal to PI. You have read this formula in class 10th also. So only the formula for depth of discharge SOC and that you need to remember. Okay. The rest of thing big formulas are just balancing the equation. So don't worry about it. When you try, I suggest you guys please practice more question. Otherwise you won't be able to solve it in the final exam. Okay. Practice more. Try to solve at least 20 questions based on this. Okay. Or the same question solved it 20 times. You will understand it how to solve this type of question. So thank you once again for attending this live session. So it was a fantastic live session with you guys.